In this video, we will be looking at some of the main ideas from Section 2 of Chapter 2. Here are our learning targets. This section talks about three important laws. The first law you already know, the law of conservation of mass. Mass is neither created nor destroyed in a chemical reaction, or the mass of the reactants is equal to the mass of the products. Another law is the law of definite proportions. This states that for a given compound, you always have exactly the same proportion of elements by mass. For example, if you have two samples of carbon dioxide, so this is the same compound, and that carbon dioxide, if decomposed into its elements, has 25.6 grams of oxygen and 9.60 grams of carbon. And then there's another sample that gives you 21.6 grams of oxygen and 8.10 grams of carbon. We're going to show that these results are consistent with the law of definite proportions. I'm going to compare the mass of oxygen to carbon for each sample. For the first sample, I get 2.67, and for my second sample, I also get 2.67. This is the same ratio by mass, so this verifies our law of definite proportions. And remember, if you take the masses of each of the elements, convert those to moles, and do a mole ratio, that gives you the chemical formula. Each of these would give you CO2 as your empirical formula. And our third law is the law of multiple proportions. So we have definite proportions and multiple proportions. This is for the same elements, but they're in a series of compounds. So definite proportions was just for one particular compound. This is for a series of compounds, but they will be composed of the same elements. The ratio of the masses of the second element that combine with 1 gram of the first element can always be reduced to small whole numbers. So for example, compound 1, which is going to be carbon monoxide. For every 1 gram of carbon, there's 1.33 grams of oxygen. Compound 2, carbon dioxide. For every 1 gram of carbon, 2.66 grams of oxygen. These are in a 2-to-1 ratio. And this is the law of multiple proportions. Compare the masses of oxygen for every 1 gram of carbon, we get a small whole number ratio, 2-to-1. Here are some representations of carbon monoxide and carbon dioxide. Here you can see we've got the 1 oxygen, and here we've got 2 oxygens. So we see twice the mass of oxygen for the carbon dioxide because there are twice the number of atoms. And finally, we're going to look at a problem, nitrogen-oxygen compounds. So several compounds. So we're looking at our law of multiple proportions. NO2, 2.28 grams of oxygen for every 1 gram of nitrogen. N2O, 0.570 grams of oxygen for every 1 gram of nitrogen. So we have to have the common, 1 gram of an element, in this case nitrogen, and then we can compare the masses of the oxygen. When we compare the masses of the oxygens in the two different compounds, we get a 4-to-1 ratio. We get a small whole number ratio. This is showing our law of multiple proportions. When we compared carbon monoxide and carbon dioxide, each one of those molecules had just 1 carbon, and then we could really easily see that carbon dioxide had twice the mass of carbon monoxide in terms of its oxygen atoms. That's a little bit harder to see here because we have different numbers of nitrogen atoms in our two formulas. But if we kind of want to put it on a level playing field, think about what the formula would be for NO2 if we wanted to have two nitrogens just like we do right here. That would be N2O4. And then we can see 4 times as many oxygens here as here.